In this third video, we're going to be looking at encapsulation. Encapsulation is a really core idea in object-oriented programming, and in the exam, you'll be expected to be able to do encapsulation, constructors, classes, and objects in terms of coding and be able to understand, read, and use code. So encapsulation is a really simple idea. It's where we hide the inner workings of a class from the outside world. And when we say outside world, what we really mean is from other objects and other classes. So when someone is using class, we don't necessarily want them to know how the class works. We want to see it as a little bit of a black box. So the black box of the class will allow you to use methods. I'll just put a little M for methods, but not use the attributes. Okay, so the attributes are the variables of the class. These are the data that describes it. We don't want people to have willy-nilly access to it, because if they did, they might change it in a way that was not expected, which might then break the code of the class. So it's very similar to the ideas of global variables, where global variables, if they change in the wrong way, could end up breaking other functions. So ultimately, we don't need to know how code works. So here's an example. Now imagine you didn't know how we code the stack. So I've created my stack, and then I've got .push. Now .push, we know what stack does, so we don't need to know how push works in order to be able to use it, because we know what the end result will be. So if you have a quick look at this code, what would be displayed when I did my stack.pop, hopefully we'd have worked out very quickly it's G, because I pushed D onto the stack, then O, then G. G is going to be the top of my stack, so it prints G. Okay, so you don't need to know how the code works in order to know that G would be displayed. Have a think about some of the classes you've already used. For example, like a list class in Python. You probably would have used append. Now append will add a value to the end of a list. Now, how does it do it? I don't know. I'm sure if I went into the Python code, had a good look at it, I'll be able to work it out, but I don't need to know. All I need to know is what does it do. That is at the essence how encapsulation works. Now, encapsulating attributes is really important. We don't want the outside world having access to attributes of a class, because if they did, they might mess around with it in a way that's not expected. So we tend to have these setters and getters, as they're called. Okay, so set previous and get previous. So in the start class, the node class in the stack, we had a previous attribute, which basically points to the next item in the stack. And we also have a value which we want to get from the stack. Okay, so here, instead of just simply using attributes directly, I've applied some kind of wrapper class methods to allow access to it. So the reasons why we do that is because we can perform validation on it. So let's say I try to set a previous that wasn't a node. I could possibly put some validation in there to check that. What if there wasn't a value in this node, or maybe I could do validation there. Okay, so it allows me to do some validation. It prevents outside coders from changing attributes in ways that could break other class methods. So it allows me to control how those attributes are used and accessed. And accessing the attributes directly meaning you do need to know how the code's working, which means you'd have to read through the code, you have to understand it, rather than simply knowing you can use it. So it is a way of protecting attributes. Now, in Python, this isn't as clear, but in pseudocode and other programming languages such as Java or C++, it is very clear. And we've got this idea of private and public. Now, private means that it can only be accessed within that class. So only methods within that class and other attributes within that class can access a private method or attribute. Public, on the other hand, means it can be accessed by other classes and other objects. So any public methods can be used. For example, here I've got a constructor, and that's public. If I didn't have a public constructor, then I couldn't create any objects from it. So my constructor is public. However, you can see my value here is private. So that means I can't just simply create a node and access this value directly. So I'll have to use that idea of get value. Same way, if I want to change the previous node, I'd have to use this public function rather than just going straight to previous, because I've made previous private. So we've got these two very simple ideas. Public methods can be accessed from anywhere, private can only be accessed within the class, and we tend to use private to hide attributes of that class and essentially encapsulating them. So rule of thumb, if you need to use an attribute or method from outside the class, then we make it public. Any attribute which is only used internally, i.e. top of the stack, we don't really want to show the top of the stack, we make it private. Attributes in general should have getters and setters, so get used to having getters and setters for every attribute, unless you really don't want anybody else to see it from the outside the class. And any attribute which is private, which uses getter or setter methods, we say it's been encapsulated. Encapsulation, what I've just gone through is like the basic introduction to it. It's well worth doing some further wider reading on it. So here I've got two websites which I think explain encapsulation well and explain some of the reasons why we use it. So it is, I tell you, it's probably a good idea before you really get into the coding using encapsulation, you actually have a bit of research on it. Before we get into inheritance, it's a good idea to really practice the core ideas of programming that we've looked at so far. Okay, so we've looked at classes, objects, constructors, encapsulation. That is the core idea of the exam. The exam won't be asking you to create inheritance code, but it will be asking you to do coding using the four that I've just mentioned. Okay, so you need to be able to read and understand OO code. So if they give you an exam, you need to know what it looks like and read it. You need to be able to create your own constructors and assign values within it. You need to know how objects are created and instantiated and how they're accessed, and use objects as part of a solution to a problem. So this is where you need to start practicing your coding. So on IS Code, I've got loads of challenges for you to have a go at. Challenge 1 is essentially using adapting OO code. Challenge 2, creating new code and add classes, so maybe add new methods. Expand on existing classes and use them to solve problems. And challenge 4, kind of small little mini projects which require OO code to actually solve them. The tasks focus on the kind of code you might be asked about in the exam. Okay, you're not going to be asked to design classes in the exam because there's just not enough time. You also won't be asked to do inheritance in the exam, but you might be asked what is inheritance, or here's an example of inheritance, explain what's going on, or explain things like that. And I'll talk about that when we look at the inheritance video.